Now I'm going to share the screen. Can you see it? I believe you can. Okay. Now see, yesterday we have learned the difference between RAM and ROM. Now this is the 6 transistor SRAM cell. SRAM. That means we will see the basic structure of SRAM and DRAM cell. So there are different types of SRAM cell available, but this one is the most popular one. This is the 6 transistor SRAM cell. 60. 60 means 6 transistor. 6 transistor SRAM cell. From the name, you can understand that one cell has 6 transistors. So see this one. This is the basic construction of SRAM cell. Here you have a transistor, another transistor. Here you have a NOT gate. NOT gate has 2 transistors inside. So this is one transistor. This is another transistor. So 2, 2, 4, 5, 6. So that's why this is called a 6 transistor SRAM cell. Here, this line is called data line. This line is data bar. That means it is opposite. Normally it is opposite. If it is 1, it is 0. If it is 0, if it is 1, then it is 1. Okay. This line is called row select. That means you can select the line. You can select the row, right? This row, if you give 1, these NMOS, normally NMOSFET, this is an NMOSFET. This is an NMOSFET. NMOSFET works in 1. That means if you give 1, it will be activated. If you give 0, it is deactivated. If you give 0, it is deactivated. Okay. If you give 1, the data here will go inside. If you give 1, the data inside, the data here will go inside. That means think about this one. If it is 1 and if it is 0, if you give 1 here, this 1 will go inside. This 0 will go inside. See the loop. Think about this loop. This 1 will become 0. This 0 will become 1. So there will be a loop. In this loop, the data will bounce back, okay, or bouncing here. That means it will what is that? It will hover around here. It will remain here as long as you are keeping the power. That's why it is called RAM. SRAM is a type of semiconductor memory that uses bistable latching circuitry to store each bit. Bistable means 1 will become 0, 0 will become 1. That's why it is called bistable. Bistable latching circuitry to store each bit. So in this circuit or in this loop, your 1 bit, only 1 bit will remain. Basic 6 transistor or 60 SRAM cell has 6 transistors. Okay, what is the read write operation? I'm going to show you the write operation, and I'm going to talk about the read operation as well. So let's bring our software, that is DSCH. I'm going to stop share. So this is our DSCA software. Okay. Now here we will construct one 6 transistor SRAM cell. That means SRAM. We will make one SRAM cell here. Only one cell. Now see, we need at first we need an NMOS. This is our NMOS. This one. Okay. So double click. Do not need any properties or name. This is our NMOS. Okay. We will rotate it by using this one. Okay. Then we will copy it by using this one. Then we need a NOT gate. This is our NOT gate. We need another NOT gate, but this one should be flipped. So this is the flipping thing, okay, by which we can flip it. So our structure is ready. Now we need buttons, 3 buttons, one for data, another one is for data bar, another one is for select, row select. Okay, now let's rename it. This is our data, DATA. This one is data bar, that means opposite of data, DATA. Let's say B, data bar. Okay, now this one is our select, SELECT, select. That means row select actually. So here, let's connect. This is the loop. This is the bistable loop where the data will remain. Okay, I will show you in a moment. You will understand. The loop is created. Okay. Now this is our SRAM cell unit. Now see this one. If I turn on the simulation, you will see this thing is okay. Let's zoom it a bit. This thing is gray. This thing is gray color. That means there is no data inside. No data. Neither 0, neither 1. Here the blue lines means they are 0. If it is red, that means they are 1. Here there is nothing. Not a blue, not a red. That's why that means there is no data. That means when you turn on your computer or when you turn on your power, the SRAM do not have any data inside. That means RAM do not have any data inside, right? At the beginning. Now, you want to keep a 1 here, right? Let's say, so look at this one. For write operation, let's zoom it. For write operation, your data must be 1. If you want to write 1, right? Your data must be 1 and your data bar must be 0. If you want to write a 1, your data then should be 1 and your data bar should be opposite, that means 0. Then after that, your select should be 1. Select. Okay. We want to write a 1 here. So we will click 1 here and it should be opposite, that means it should be 0. Now, whenever we turn on the select, see that this red will go inside. See, this is gone. This gone inside, right? Just this one just got inside, and this 0 has gone inside, right? Now, if I turn on the power, if I turn on the select, that means this data is permanent now, permanently there, right? It is written. It is already written. Now, if your data changes, nothing happened. See, if your data changes, nothing happened. Nothing is happening. Your inside data will remain as it is. Okay, if it is 1, if it is 0, doesn't matter. Your inside data will remain as it is, right? That's why it is called a memory. It can memorize whatever there is, whatever data there was. Okay, so this is the SRAM cell. Whenever you want to write one, this is the 1, this is the 0. So this is the SRAM cell. So this is the write operation. That means if you want to write 1, make data is equal to 1, then data bar should be 0, and your select should be 1, right? Now let's do the opposite thing. I want to make a 0 here. So data should be 0, data bar should be 1. Whenever I select these, wait a minute. Now I want to make a what is that? 0 here, 1 here, right? So it should be 0, this should be 1. Now whenever I click select, you will see a 0 has gone there. Now a 1 has gone there, right? So actually we will take our data from here, because this is our data bar, this is a data line, right? This is our data point, this is our data bar point. So we will not take our data from data bar, we will take our data from data. That means here we will measure here whatever the thing, whatever the state we are seeing here, that is our data. That means we store a 0 here, we stored a 0. Now let's see the read operation. How do you read? Remember, for read operation, your data must be 1 and your data bar must be 1. Both of them will be 1 forcefully. Remember, normally we anticipate that our data and data bar should be opposite, but for read operation they should be 1. They should be 1, and they should be careful, and you have to make it forcefully. You have to make it forcefully 1. Then you have to select 1. Now what will happen when you make both of them on 1? When you make both of them are 1, see this one here, you have 0, here you have 1, here you have 1, here you have 1. Now whenever I turn on the select, the data, whenever I turn on the select, what is happening? There must be a current flow here, there must be a current flow there, but there should not be any current flow. Remember, there is no voltage difference between them. This is 1, this is also 1. So there is no voltage difference and there will be no current flow in this path. But here you have a what? Here you have a 1 and here you have a 0. So there will be a voltage difference and there will be a current flow in this path. So the controller of SRAM will sense a current flow. If there is a current flow here, that means it was 0 previously. If there is no current flow here, that means there was a 1. There was a 1 inside. That means, see this one. If this was 1, this was 0. Now for reading, you have to make them forcefully 1, both of them. Now whenever I turn on the select, what will happen? This is 1, this is 1. So there will be no current flow. That means there was a 1. If there is no current flow, there was a 1. Okay. If it was opposite, like this one. Now whenever I turn on the select, there will be a current flow now. So it was a 0. It must be a 0. If current flow exists, that must be a 0. If there is no current flow, that must be a 1. So your SRAM, what is that? Controller will sense, will sense, is there any current flow or not? If there is a current flow, that means your SRAM data was 0. If there is no current flow, that means your SRAM data was 1. So by this method, your controller will understand what was the data inside. Okay. Now I'm going to enable the presentation again. Now this is how you read and write data. The next one. Switch off. Okay. Now see, this is a row selection decoder, 4x4 row selection decoder. What do you mean by row selection decoder? Normally, SRAM cells are situated in a row, in an array, like this one, in an array. Here you have one SRAM cell, one cell, one cell, one cell. So you have 4 cell, and you have 4 line. That means 4 row. 1, 2, 3, 4. 4 row, right? Normally it is 8 into 8 or 16 into 16 or 16 into 1000, something like that. But they are called array. Okay. So since they are situated in array, normally the SRAM are constructed in array. Not only SRAM, every RAM actually, they are created in an array. When they are created in an array, remember this thing, they must be selected, they must be controlled by a row selection decoder. Why? Because you have lots of row there, but you cannot control them easily. So you need to use a decoder so that you can give less input and control most of them. Now see this one. This is a normal decoder, row selection decoder. What is the purpose of this? If you give 0, 0, this row will be selected. That means 0 number row will be selected. If you give 0, 1, that means number 1 will be selected. If you give 0, 2, this one, not 0 2 actually, 1, 0, this one will be selected. If you give 1, 1, this one will be selected. Why this is necessary? Because I want my data to go in a particular row, right? I do not want my data to go in every row. I want, let's say, I want to save my data in this line, right? In this row, I want to save my data in this row. Let's say I want to save 1, 0, 1, 1. So this data must be going in this row. So I want to select this. I do not want this data to go every row, right? That's why I need to individually select the row, individually. So this is a very good example of row selection, because if you give 1 and 0, only this row will be selected, no other row will be selected. So let's see the truth table. A, B, you have 2 inputs and you have 4 outputs. Row 0, row 1, row 2, row 3. Now, obviously, if you want to select more rows, you have to increase the number of inputs, right? If you want to select 8 rows, that means you need to select, you need to have 3 inputs, A, B, and C, like 2 to the power 3, 8. So here we have 4 rows, that means 2 to the power 2, we need 2 inputs. So 0, 0, your row 0 will be selected. That's why this is 1, others are 0. 0, 1, R1 is 1, others are 0. 1, 0, that means number 2 is selected here, others are 0. 1, 1, that means R3 is selected, others are 0. Understood? Now from here, we can make one logic expression. Row 0 is equal to A bar B bar. Row 1 is equal to A bar B. Row 2 is equal to A B bar. Row 3 is equal to A B. Understood? Now, what will happen? So this is the logic expression. Now we want to make a circuit from here. So this is our A, this is our B. So A must be there and A bar must be there. So there is a NOT gate. B is there, B bar must be there. There is a NOT gate. So this one, there's a mistake here. If you see, there is a mistake. So this line is not connected to anywhere. So this R0 must be connected to your A bar and B bar. R1 must be connected with A bar and B. Then R2 must be connected with A directly to B bar. And R3 must be connected from A and B directly. So This is the mistake. Here A bar and B bar, they are connected together, so they should not be connected together. This one should go there and this one should go there. Okay, this is the mistake. So I'll show you how to fix it. So let's say we want to make a SRAM array. Array means we want to make a big array. That means this one, big array. Now remember, for selecting the rows, you have a row selection decoder. For operating the lines, that means the data line, you need a column decoder. This is called a column decoder. Now this is a column decoder. Column decoder, I will explain what is the operation of column decoder. Column decoder has two lines. One is data, another one is data bar. Remember why this is necessary? Because sometimes the data and data bar should be opposite, 1 and 0, 0 or 1. Sometimes they are same. That means both of them will be 1, 1. When we want to write data, that time data and data bar, they should be opposite. And when we will be reading data, they should be equal. That means 1, 1, both of them. And we need to enable the read and write operation. That's why this circuit is necessary. So here you have two MOSFET, not NMOS and NMOS, and their gate is connected with line select. That means whenever you want to select the line, this should be 1. Then they are enabled. Okay. For writing, so I want to make my circuit understand I want to write or read. So there must be something by which I can give the SRAM a signal that I want to write or I want to read. That's why these two tri-state inverter, they are called tri-state not gate. Tri-state not gate. Tri-state not gate means they have 3 state. Okay, 3 state means either they are 1 or 0 and they have another output that is called Z. So let's create this first. How to create this? Okay. I need not get. This is the not get, the properties. Now I will copy it. Now I need tri-state inverter. This is the tri-state inverter. One is here. Copy. Another one is here. I need a not get. Here is the not get. I need buttons. One is this one. One is this one. One is this one. So this is called line select. This is called write. And this is your data. Yeah, like this. Now here, their gate must be connected. This one. Same line. Now see what I just made here. This is a row selection decoder. No, not row actually. This is a column decoder. Here you have two NOT gates. One, another one. So your data will be, this is, if this is 1, so this will become 0. This will become 1 again, right? So your 1 remain as 1, and for this one here, this is your 1, so 1 will become 0. So this is your data line, this is the data bar line. So when it is 1, this is also 1. When it is 1, this is 0. That means the data bar line, right? But these 1 and 0 will not go to your SRAM unless you select the line. And these 1s and 0 will not go here unless you select the right. So let's see what is happening. See, these are gray, right? These lines are gray. This point is gray, this point is gray. That means the no data will go inside your SRAM. Now here you want to write or you want to keep a 1. See, nothing happened. If you give 1 or 0, they are not changing because you are not enabling them. So if I give 1, see, this 1 should come here, but this will not come unless you click the right. If you click the right, they will go and come at the beginning of your NMOS, but they are not going there yet. Not yet. Okay, they are not going there yet. Once you select the line, now they will go. Okay, see, once you select the line, they will go there. When you unselect the line, they will stop. Okay, this is called row selection. This is called column decoder. Column decoder. I will make you understand why they are necessary. So let's save it. This is called column decoder, right? Column decoder 25. So I'm going to save it. I'm going to stop the share. So I believe we have learned something here, and tomorrow, that means in the next class, we will be building a SRAM unit, total SRAM unit. That means like this one. We'll be making a total SRAM unit like this one, and we will store some data inside. Okay, that is for tomorrow. And if you have a question, you can write in the Facebook chat group, and good luck for your next class. Okay. Abdiaziz, I recorded the class, so I will upload the class there. If you need it, you can ask me. Okay.
Yes.
Okay.